Hello everyone and a very warm welcome to my channel. In today's video, I will guide you step by step through creating a three-dimensional polar plot in Matlab using an engaging and practical example from electromagnetic field visualization. So you will see that how to simulate a directional field pattern using polar coordinates and transform it into an interactive 3D plot. So that is perfect for beginners, and this tutorial walks you through each line of code and explain how polar data can be visualized in 3D space. That is ideal for physics, engineering and data science projects. So let's get started. So for creating a editor window, we need to click on new script. So we need to start the code from CLC, clear all and close all. After that, we need to define the angular and radial values. Okay, the example that I am choosing is a simulates an electromagnetic field intensity distribution with a unique radial variation pattern. So for that, I am defining my theta. Okay, initially I need to add the comment. So define angular and radial values. Okay, so initially I'm going to define the theta. So theta is equals to linspace, and inside I'm choosing 0 and ending at 2 pi, and want to divide this range into 200 equal parts. After that, I'm defining my radius from center. So r is equals to linspace, and we need to start from 0.01 and ending at 1, and we want to divide it 100 equal parts, right? Okay, after that I'm going to create a mesh grid. So theta comma r, and we have to define mesh grid, and inside we have theta comma r. Okay, after that we need to convert the x and y values into a Cartesian coordinate. So convert to Cartesian coordinates. So for that, I am choosing x is equals to r dot steric cos of theta, and after that we have y that is equals to r dot steric and sine of theta. Okay, after that I'm going to define my function for field strength. So I just simply add my comment that define a z function for field strength. So that is basically simulates directional lobes that is often found in EM, that is electromagnetic field patterns. So we need to define z is equals to r dot steric. We have exp exponent to negative r dot steric abs, and inside we have sine, and inside we have 4 theta. So after that we need to plot this three-dimensional polar plot. So for that, plot the 3D. So we need to customize it. So firstly I'm going to write figure, that opens a new figure window. After that, we want to plot a 3D surface, so x comma y comma z. After that, we need to define the title, so 3D polar plot of electromagnetic field pattern. After that, we need to define the x label, so I'm just setting it to x axis, y label, and I'm setting it to y axis, and z label, and we need to set it to field intensity. And after that, I am defining a color map to cool. Then I want to see a color bar. Okay, we need to run it. Okay, so this is our 3D polar plot of electromagnetic field patterns. So I am just adding one more statement, that is shading enter P. So this will plot a graph with a plane shading. Okay, so this is the top view, this is the bottom view, and this is the front view. And when I rotate it, so it's look like a flower. So this 3D polar surface plot models a radially decaying electromagnetic field that oscillates with angular direction, and the height z, this is the height z, that represents the field strength at any given angle and distance from the source. So this lob structure reflects additional emission or field strength. Secondly, this decaying field from the center outward mimics natural electromagnetic waves attenuation, and the color gradients enhance the visibility and interpretation of the field intensity. And that's it. If you enjoyed this tutorial, give it a thumbs up, subscribe, and hit the bell icon so you never miss a Matlab learning videos. Have any questions or want to see 3D polar plots using actual data, drop your suggestions in the comment below. So thank you so much for tuning in. I'll see you soon in the next video. Stay blessed.